A circle is a special case of an ellipse. When the focal distance is 0, the two foci coincide at the center, the major and minor axes are equal in length, all points on the ellipse are equidistant from the center, and the ellipse loses its typical oval shape and becomes completely circular. The eccentricity of an ellipse is a number between 0 and 1 that determines the shape of the ellipse, that is, how elongated the ellipse is. To calculate the eccentricity of an ellipse, we divide the focal distance of the ellipse by its semi-major axis. In mathematical terms, E equals c over a. The focal distance is the distance from the center to either focus, and the semi-major axis is the distance from the center to either vertex. For an ellipse to exist, the semi-major axis must always be strictly greater than the focal distance. The closer the eccentricity is to 0, the more the ellipse resembles a circle, and the closer the two foci are to the center. If the eccentricity is 0, the two foci lie at the center, and the ellipse becomes a circle. Conversely, the closer the eccentricity is to 1, the more elongated the ellipse becomes, as we will see in the next several minutes. In a highly elongated ellipse, the semi-major axis is significantly longer than the semi-minor axis, and the foci move farther away from the center and closer to the vertices, but they never coincide with them. The orbits of the planets in our solar system are elliptical, but their eccentricities are low. For example, Earth's orbit has an eccentricity of about 0.0167, which is very close to a perfect circle. And Mercury's orbit, which is the most eccentric orbit of all the major planets, has an eccentricity of about 0.2056, indicating that it is somewhat elongated, though not highly so. Dwarf planets typically have more eccentric orbits than the major planets in our solar system. For example, Pluto's orbit has an eccentricity of about 0.2488, making it more elongated than those of the 8 major planets. This means that its distance from the Sun varies more significantly during its orbit compared to the distances of the other planets from the Sun. Eris' orbit has an eccentricity of about 0.4361, and Sedna's orbit has an eccentricity of about 0.8496, resulting in a very elongated orbit that takes it far from the Sun. Many comets have highly elongated elliptical orbits, bringing them close to the Sun before swinging far out into the solar system. For example, Halley's comet has an elliptical orbit with an eccentricity of about 0.9665, making it highly elongated. Halley's comet takes about 76 years to complete one orbit around the Sun. Comet Hale-Bopp also has a highly elongated elliptical orbit with an eccentricity of about 0.9949. Comet Hale-Bopp's orbit is so elongated that it takes about 2,533 years for the comet to complete one orbit around the Sun. Like, share, and leave a comment. Thank you for watching, and don't forget to subscribe to my YouTube channel.